In this video, I want to answer the question, how can we tell if a table represents a function? So since this video is leading up to graph isomorphism, it makes sense that our tables have information about graphs in them. So the graphs that we'll use for our tables here are these two graphs here, G and H. In fact, we'll just use the vertices, the vertex set for G, which is this set, and the vertex set for H, which is this set. Now something that's kind of new is this notation V of H and V of G. The problem with using our old notation, just V and V, is that we don't know which vertex set we mean when we say V. So that's why we use this notation, V of G, V of H. So the vertices of G and the vertices of H. Now here we have two relations, this relation here and this relation here, that may or may not be functions. This one here, this is F1. This is a relation that may or may not be a function. And here we have F2, which is a relation that may or may not be a function. But in any case, this notation here and here still makes sense. This notation right here, this is just saying this is the relation F1 from the vertices of G to the vertices of H. And this right here, this notation is saying this is the relation F2 from the vertices of G to the vertices of H. So now remember that a relation is a function if it passes the vertical line test. So now let's see if F1 passes the vertical line test. Right, from the rows of our table here, we see that V1 goes to U1, so we have that point. V2 goes to U3, so we have that point. V3 goes to U2, so we have that point. V4 goes to U4, so we have that point. And V1 goes to U4, so we have that point. And now you can see that F1 does not pass the vertical line test. So that tells us that F1 is not a function. All right, now let's look at F2. Our table for F2 tells us that V1 goes up to U2, V2 goes to U1, V3 goes to U4, and V4 goes to U3. And here you can see that F2 does in fact pass the vertical line test. So that tells us that F2 is a function. All right, so now how do we tell, so what is it about these tables that tell us if something is a function or not? So look at the first columns. In the first column for F1, notice that there are repeats. V1 is repeated. In the first column for F2, there are no repeats. So repeats and no repeats. So if there's no repeats in the first column, then the table represents a function. But there's one more thing I should say. We can make this table have no repeats in the first column simply by deleting some of the information. So what I mean is, let's say that you didn't write this part down right here. Let's say you didn't write that part down, even though that is part of our function. Then there would be no repeats, and you would think that it is a function. So the point here is that you must represent all of the vertices of G in the first column. If you do that, and there are no repeats, then we know it is a function.